Right then, okay, so I guess we're streaming. I'm not used to streaming, so hopefully you can hear me and all my settings are right and it's streaming. Looks like it is. Okay, so welcome to this talk as part of Global at Azure. We're going to look at a couple of experiments I did to teach myself or introduce myself into the world of machine learning, specifically with C# and .NET. So we're going to look at machine learning with cartoon characters and Christmas trees. Right then, okay, so I guess we're streaming. Not used to streaming, so hopefully you can hear me and all the settings are right and it's streaming. How do I turn that off? Okay, so welcome to this talk as part of Global at Azure. We're going to look at... There we go. Sorry about that. Told you I'm a newbie when it comes to this sort of stuff. Right. There we go. Next slide. Right, who am I first of all? So my name is Lee Engelston. I'm the developer relations lead over at Avanade. They are an IT consultancy formed by Microsoft and Accenture 20 years ago. We're about 50,000 of us worldwide at the moment. I'm also Microsoft MVP in developer technologies, and I have been for the last couple of years. I enjoy building websites that I think other developers will find useful, things like visualstudiotips.co.uk and more recently techcommunitycalendar.com. Go check those out if you haven't already, and giving talks like this and sharing things that I've learned to see if it will help other people. I've also written a book on augmented reality for .NET developers if they want to experiment with AR for their mobile iOS devices using C# and .NET. So there's a bit of a light time reading there if you want to check that out as well. Right, okay, who are Avanade? We've got to briefly just say what a wonderful company Avanade are. There are lots of great reasons to work here. If you're looking to move on, come and reach out to me or look at careers.avanade.com. We have things like global innovation contests. We've got like 50 Microsoft MVPs working for us. We're one of the founding members of the Green Software Foundation. We've got structured career paths, dedicated careers advisors, all great things going on there. Right, on to the talk while I check my settings and double check I'm still streaming. It still looks good. I think I'm streaming. Right, okay, so this talk is very much a talk of two halves and two experiments I've done. So the first half we're going to look at me training a image classification machine learning model locally on my laptop, and then taking that, getting it working with a console application, and then hosting it in an Azure function, and then calling that Azure function from a website. And you'll see the use case for that in a minute. You might have guessed already by the URL. And then in the second half of the talk, we're going to look at another experiment I did, this time training an image classification model completely online and in the cloud using customvision.ai, and then again creating a dedicated website to then call that endpoint as well. Both interesting, not sure how useful they are, but interesting and fun experiments. Right, I just want to talk about my motivation a little bit for learning machine learning. So a few years ago now, Microsoft created a few websites which if you have to really think back to remember, it did one called whatdog.net, where you could upload an image of a dog, and then it would very, very cleverly tell you what breed of dog that was. And back then, before AI was really sort of becoming popular, this looked like magic, and everyone was like, well, how does it know what kind of dog that is? That's amazing. And then people started uploading images of themselves and their friends, and then it started saying what kind of dog that they look like. So, yeah, fun little use case there. And then later on, they created another website called howold.net, where you could upload an image of yourself or other people, and it would guess how old the people, I say guess, it would try and determine how old that person was in those images based on machine learning and AI that it's done previously. It always aged me a bit on the older side, so I don't have the fondest of memories of howold.net. So I saw these websites and I thought these are amazing. I need to know how these work. So I looked up Microsoft's own machine learning framework, ML.net, downloaded a code sample and started from there. Coming from a Microsoft background, I wanted to use C#, so I didn't want to use Python, and initially anyway, I wanted to try and do it all locally. So this is what we're going to talk about next. Just want to put out there as well, I am not a machine learning, AI or data science expert. I'm just telling you a couple of experiments that I've done in this area. So we're going to be using something called transfer learning, and that means we're not building an entire image classification machine learning neural network from scratch. We're kind of building on top of an existing one, in this case one called ResNet, which is already very, very good at trying to determine what's in an image, and we're kind of just specializing it with our own use case and extending it slightly. So we're kind of very much building on top of something that's already there, hence the name transfer learning. So when I started looking at how ML.NET work, I did what most people did and looked at the docs and downloaded the code sample, and it worked. Don't get me wrong, it all worked fine. But the sample was a bit boring, I found. It was how to define cracks in concrete tiles, I believe. Don't get me wrong, pretty important use cases if you're casing a nuclear power plant in concrete or something like that. But for me, a little bit on the boring side. And for me, if I'm to learn something, I have to make it interesting. So I thought, well, how can I take this code and create an image classification model that I find a bit more interesting? And I came up with, don't ask me why, cartoon characters. I thought, I'll keep it simple. I will choose a topic where I can readily get lots of different images for it. And I will choose something that's very easily classifiable for the human eye, but let's see if a machine learning image classification model can do the same. So if you look at the cartoon characters at the top, you've got Iron Man, Thor, Spider-Man, Falcon, Wolverine, Silver Surfer, all smiley, very happy, lots of muscles, nice bright colours. And we can look at them and we think they're definitely goodies. Whereas if we look at the bottom images, I think we've got Ursula from The Little Mermaid, Malevolent, Jafar from Aladdin, and I think Hades from Hercules. These are all bad guys. We can instantly look at these people and determine those are definitely baddies, without even knowing what film they're coming from in most cases. So I wanted to create an image classification model to see if I could give it an image of any cartoon character and it would tell me if it's likely to be a goodie or a baddie. Is it good or is it evil? And I had no idea if this would even work. So that's where I started from. It did make me think, slight tangent here, it did make me think, why do I think some of these people are evil and why are some of these good? And it did start me looking at how our human brains work, and it turns out we have like a dedicated part of the brain which is constantly scanning the environment for faces, and that's why we see everyday faces in everyday objects. And not only can we see faces in everyday objects, but we almost infer a kind of an emotional state of these objects. Like you can see a happy cup of coffee here and an angry mop and an angry typewriter. So I actually went off and did a separate talk on analysing faces with and without code. But that's a bit of a tangent. Back to the main event. Yes, goodieorbaddy.com, training an image classification model using ML.NET. Thanks for sticking with me. Right, so what we're effectively doing is creating a neural network, or in the case of ResNet, sort of extending or tweaking one. The way we do that is we get a load of images that we think and label them. And I started off with a bunch of images with a label of good and a bunch of images which I label as bad. And I want to create something, this neural network, this image classification model, which when I feed an image through the input layers, it will do, it's quite magic for now, magic in the middle and output the classification on the output as good or bad. Now, what the magic that's happening in the middle is actually us training the model. And as we feed the images through, along with our label, if we think we want the model to determine this as good or bad, it's actually applying different weightings and functions to neurons and connections between those neurons. It's all maths at the end of the day. So that's what eventually happens is once we've put all our training data through, it kind of creates weighted paths through the neural network for these images. And what it does is when we then bring some test data like these two images, we've got Super Ted at the top and then I think Cruella de Vil from 101 Dalmatians at the bottom. If we push it, each of those images will take a different path through the neural network, through the different weightings, and eventually end up on the output layers and to receive its classification as either good or bad. And that's effectively what we're doing when we're training this model. I've glossed over a lot of the low-level detail, as you can see, but I just wanted to know what we're actually doing. Okay, so these are the steps that I took. taking the cracks in the tiles code from the docs, I started to download all the cartoon characters that I wanted to use. So I ended up with 70 images of baddies and 70 images of goodies, sorry. Totaling, if your maths is sharp, 170 images. And one of the first things you need to do is have some test images or test data that you're not including in your training data, because you don't want to sort of have any you don't want to kind of cheat and have the answer inside your model, really. So yeah, don't include the test data in the training data. So I got my 2 pots of training data there. Then, just a quick word on bias before we get to step 2. So bias is a problem in data science. I do know that much, even though I'm not a data science expert. So I did immediately think about, I'm manually curating the images I use. I know bias is a problem. What if I'm choosing more female goodies than baddies? What if my eye is drawn to more red images that are baddies than good? And this is a problem. And if you do ever do proper data science, you need to make sure that you've got proper mechanisms to not introducing bias. But I decided to give myself a break for this. It is just an experiment. This isn't production data, but just be conscious of bias. And then garbage in is equals to garbage out, is the old data science adage. Right, step 2. I had my 2 pots of images, goodies and baddies, and I ran the code, but it didn't work. I googled around the very cryptic error message I had, and it turns out that if you're using ResNet as a architecture, image classification architecture, the images needed to be 224 by 224 pixels. So I had to go off and resize 140 different images, or however many images that was in my training data, and that took a while, as you can imagine. So did that. Ran the code again. It didn't work. So then, out of desperation, really, and noticing that in the concrete crack example, there was a lot more than 140 images. So out of desperation, I selected all the images I had, all my 140 images, Control-C'd them, Control-V'd them, duplicated them. I had 2 every image. And I ran the code again, and it worked. It produced the image classification model. Now, at this point, if you are in data science or machine learning or an AI expert and know a lot about it more than I do, you're probably shouting at your screen saying, "You crazy fool, what are you doing? You just duplicated all your data." I did. I apologize, but it worked. So yeah, moving on. We have to do crazy things to make things work sometimes, but it would turn out that the next gotcha is there seems to be some sort of minimal number of images needed between 140 and 280, and I'll be damned if I know what it is, and I'm not about to experiment finding out what it is. But yeah, I did have a working image classification model. So then the next thing to do is run your test images through. Of course, remember, aren't included in your training data. So I ran my 3 images of bad guys that weren't in my training data and 3 images of good guys that weren't in my training data, and it managed to identify them with 100% accuracy that the baddies were baddies and the goodies were goodies. And at that point, you immediately think, this isn't right. I've done something wrong. I need to go back and check my code. It can't be that easy. Well, not easy, but it can't have got this 100% accuracy. This must be wrong. Turns out it was right. And if you do this and you download this code that is on GitHub at the moment, or you create an image classification machine learning model or something like this, once you've done it for the first time, it's very awe-inspiring. You've managed to create something that appears to have some sort of intelligence. It's actually somehow able to but be given an image and somehow, in this black box of neural networks and weighted neurons and pathways, determine that it's a good or a bad image. So I do recommend you try that. It's a bit of a weird feeling when you do this the first time. So I had a console application that would do this, but I didn't want to stop there. I thought it's not very useful, really. How many people are going to be really running this image classification model on the console application? So I decided to see if I could put it in an Azure function and call it from there, somewhere that anyone could hit that endpoint. and pass up an image and retrieve a JSON response. So that is what I did. A couple gotchas if you do this. If you're running it locally, you need to have some cause values for your host in your local settings JSON, otherwise it won't let you do it. And also when you do finally have your Azure function live and you want to call it from another website like goodyourbaddie.com, which we'll look at in a minute, you need to allow that, put it as an allowed origin in the cause section of your Azure function. Okay, so I then had an Azure function that worked. I managed to call it with Postman, you have to believe me. So I thought, well, this is great. Now I want to create like a better front end so that I can allow other people to upload images of cartoon characters to share in the fun. But I decided I didn't want to create a fully blown ASP.NET web application. I wanted to experiment to see if I could trigger this functionality and hit this Azure function using just a flat HTML file instead. So this is what I did, and I'll briefly describe how I did that. So I have a single HTML file that just contains all the JSON, all the JavaScript and the CSS and the HTML. And I was hosting that on GitHub Pages. I've never done that before. It's kind of neat. It didn't actually cost you anything, so it's a great way of hosting something very simple if you want. And if you're going to do this locally, another hint or tip I can give you is to use the live server plugin for VS Code. It's fantastic. If you open a flat HTML file in VS Code and run live server, you will find that it just spins that up as if it would, as if it was serving off a web server. Fantastic plugin there. So I also decided to use Dropzone JS. So rather than encouraging people to click a browse button and an upload button, I thought, well, let's just allow people to drag images or files straight onto the canvas, upload it to the Azure function and get a response back. So that's what I did, and we will give it a go next. This is what it looks like. My design skills are somewhat lacking and could be improved, but there it is. Let's look at the architecture. I've already mentioned this before we look at the demo, but here we go. We have the DNS for goodyourbaddie.com, points to GitHub Pages. That just hosts an HTML file, which allows you to upload an image. I'll get my pen. I like drawing on slides until it goes wrong. Upload my image to the Azure function. The Azure function holds the image classification model that we created locally as part of the console application, where we fed it a load of test data, and that's in there as well. Now that image classification model did end up being rather large. It ended up being 160 megabytes, which was surprising, but I'm sure that I could cut that down if I wanted to do a bit more of a compact underlying image classification architecture or something like that. Okay, I said I was going to show you a demo, didn't I? I'll do that in a minute. So one person then said, what about cartoon characters that started off good and then went evil? And I had to sort of laugh to myself at this sort of comment because I didn't really have a response, but I decided to try it out. So a bit of a spoiler coming up here. If you've ever seen or not seen Frozen, maybe cover your ears. I've seen it about 10,000 times, so I know pretty well what happens in it. There's a guy who is looks like he's good at the beginning, and I uploaded an image of him to goodyourbaddie.com when he was good, and it said, yep, this is a goodie. And then he ends up turning evil at the end, or towards the middle. And then I uploaded an image of him when he was evil, and goodyourbaddie.com said, yes, this is definitely a baddie now. So interesting, I thought that same cartoon character, different sort of facial expressions, different points in that story, different morality, and he managed to discern one was a goodie and one was a baddie. Okay, demo, just to prove that it's not all smoke and mirrors. I wouldn't do that to you, I promise. Right, here we go. So this is a live site. You can test this at the moment, goodyourbaddie.com. So I can drag an image onto the little drop zone here. It will send that off up to the Azure function, and we'll look at the code next in case you're curious. And it'll come back and say, this is a goodie or baddie, unless something goes wrong. Come on. Yay, goodie. Let's try another one. Let's try Skeletor from He-Man. Uploading that. again, baddie, fantastic works. It's not 100% accurate, don't get me wrong, but it's pretty darn accurate considering how little effort I put into it. So let's have a look at the code rather briefly for goodyourbaddie.com. I don't want to go through all of this because it's quite lengthy, and all I'm doing is really tweaking the code that I downloaded from the cracks in the concrete tiles use case from the official docs. But if you do go and pull this down, the first thing you'll need to do is actually create the model. And some of this, I'll walk you through some of this code. And this is what this does, is in this this program CS file, I've got a path that I want to output the model. You'll need to uncomment this to create the model to run it the first time. Let's go see what's happening in there. It did actually take 7.5 minutes to create the model. This was locally on my sort of medium powered laptop. So then I've got a path towards where my training images are. And in there are two subfolders, one called good and one called bad. And then we are using a lot of code from this ML, from this Microsoft.ml namespace, Microsoft ML Division namespace. Here. So this ML context is a pretty important class, and among other things what we're doing here. So we're loading the images from our testing directory, training data directory, and then saying use the folder names as labels, so either good or bad. And then we're getting all the image data, we're shuffling the data. I'm going to really gloss over some of this code because I don't understand what some of it does. Creating a processing pipeline, processing the data, splitting the data so that internally it can work out if it's along the right tracks with coming up with the model based on the labels and the output classifications. Create a training set, validation set. These are the options for the image classification model trainer. Here, you see here the architecture that we're using is ResNet. You can use other ones. This is creating the training pipeline, and then we are creating the model, and then I'm saving that model to that zip file at the beginning, and then I can reuse that because it takes 7.5 minutes to create every time. I definitely want to save that off somewhere to reuse it. And then what I'm doing in my function, in my Azure function, is I ended up creating a class library and abstracting and refactoring some of that earlier code. So I just had an image classifier in this library class here, which all it did was took an array of bytes, which was the image, ran it through the prediction model, prediction engine to determine the classification or the predicted label, and then I'm calling that from my Azure function up here. Pretty simple stuff really. That's all the Azure functions do. Not much at all really. Okay, so that was that. So I did the demo, did the code. What's next? Let's go back to the talk. Oh, there we go. Okay, so that is, if I can take my drawing pen off, goodyourbaddie.com, and you just need to use your imagination really to think what else could you use this on. So I thought of a couple of, again, fun ways you could use this technology. You could do a biscuit image classification model that would be able to determine between a hobnob and a digestive and a jammy dodger. That might be fun. Don't know how useful it would be unless you'd worked in like a McVitie's biscuit factory or something. On confectionery, you could train it on images of flags, so it'd be able to identify a flag based on an image. And this sort of project or technology is great for hackathons or side projects. So I just thought I would just mention that as well. What the duck XYZ, because .com was taken, obviously. I thought I would try and download images of different species of duck and see if it would be able to determine the species of duck that I give it. So that's another one I want to experiment with. So that kind of concludes part one of the talk, but let's summarize before we move on to part two. So this technology is pretty simple to use. It must be if I can pick the docs up and play with it. You can host it in Azure very simply, like I showed. If you do want to experiment with this, my advice is to scratch an itch, have fun, keep it simple. It doesn't need to be the most complex use case in the world. And share what you learn if you can, because that's how other people learn, silly as it sounds. Okay, and it's also open source on GitHub if you want to go and pull that down and try it locally or experiment with it. So it's a lot of fun. Okay, let's have a short intermission before the next talk. I can have a quick drink. Right, hope you enjoyed the intermission. So just a reminder, follow me on GitHub, LinkedIn, YouTube and Twitter at Lee Engleston, and also check out Avanad's jobs at careers.avanad.com, or reach out to me if that's the kind of thing you want a bit more information about. So on to part 2. So in part 1, we trained the data model locally before spinning up our own Azure function and hosting it in Azure. In part 2, we are going to use a service called customvision.ai, train it an image classification model online, which will produce an endpoint, and then call that endpoint to test out and use our image classification model. So last November or Christmas, I had the idea of, wouldn't it be great if I had an image classification model where it would take an image of a tree and tell me if it's a Christmas tree or a regular tree. Again, not an incredibly useful use case, but an experiment. I wanted to see if I could just do it, basically. Okay, so let's go and do that. So I'm going to do something different for this one. I'm not going to use slides. I'm going to actually show you the steps that I took to do it. You'll see I already have one here. One of these projects in Custom Vision AI. But I'm going to create a new one to show you the steps. So let's do that. New project. I will call it Is Christmas 2. It's Christmas Tree 2. That's what I'm going to call it. Christmas Tree 2. Not going to bother with the description. The resource, I'm just going to use one I used previously. This is going to be classification because it's going to be either Christmas tree or regular tree. I'm going to have multi-class, so each image can only have one tag. Yep, that's right. And then for the domain, I'm going to choose general compact S1, mainly because I've used this before and I know it works, but it tells me down here, lower down, what it did do, when you look at what that is, it says this is a great one to use if you want to take that image classification model and then download it and use it elsewhere, like offline on an iPhone or something. Don't forget, the one we just created was 160 megabytes. Okay, I'm going to keep export capabilities the same and do create project. Pretty nippy, this tool. The next thing I'm going to do is add the images. I'm going to do that, and hopefully it will open the right folder. Okay, so right, I have 2 folders, one full of 20 Christmas trees and one full of 20 regular trees. I started off with 20 trees just to see how many more I would need, see how accurate it would be with 20 trees or 40 trees in total. So let's see how we get on. So I can upload those like that. Pretty quick upload as well. I was quite surprised. And I'm going to say Christmas tree. Those are my tags or my labels for these images. I don't know many sites that upload the images that quick. Okay, so we've got a variety of Christmas trees on here. And my definition of a Christmas tree, by the way, is any tree that has got lights or tinsel or decorations on. There's even a cat in that one. Okay, and then let's do some more images. And do the regular trees. You'll have seen by these example regular trees, that I've also included trees that are like shaped like a Christmas tree, like didn't add it yet. I must skip the tags then. Regular tree. You're seeing, as I was saying, I've included trees that are the same shape as a Christmas tree. So these kind of triangular conifers, or not conifers, fir trees, just to see if I could get a false positive. But I'll show you how that goes. Okay, so now I've got 40 images, 20 tagged as Christmas trees and 20 tagged as regular trees. Next thing I need to do is train that model. Okay, so they go off and hit train, and I always tend to choose quick training because it tends to get me the accuracy I want, and it's not actually that slow. Okay, so I'm gonna jump over to my one I created earlier, just because that does tend to take several minutes to train, not 7.5 minutes, but probably don't want to kill time for 2 or 3 minutes. So if I go back to is Christmas Tree 1, which I created previously, it will create the project and it will have trained it. The first thing you want to do is do a quick test to see, once it's trained it, you'll get this performance screen. Sorry, hit my mic. And it'll say, you'll get some figures that say, we did its own testing and it found it to be fairly accurate, very accurate, etc., etc. 100% is generally good. And then it says here, really, 20 is not that great number for images. We recommend 50, but you'll see how accurate it is with 20, so I thought I will stick with 20. So then we'll do a quick test. You want to train this model before we start using the endpoint. So then I click on Browse Local Files. You can also give it an image URL if you wanted to, but let's browse a local file. And don't forget, we want to test it on an image of a tree that wasn't included in our training data. That's important. You'll see that I've got various test data trees to try and give it, including some very interesting trees to see what it comes up with. So let's give it a basic Christmas tree and see what it comes back with. Okay, so it's saying that tree, which is ran through that model, has a 98.4% probability it's a Christmas tree. It's pretty good to me. Let's try one that's not a Christmas tree. Okay, that's very obviously not a Christmas tree. It looks like a tree on the African savannah or something like that. It's saying it's 92.5% certain that that's a regular tree, which is what we want. Notice that depending on the higher probability, regular tree or Christmas tree will appear first. That's important for how we look at the JSON later. Just bear that in mind. Okay, let's try and confuse it a bit. Here's a person of a man wearing a Christmas tree outfit. I'm sorry, but I'm still going to class that as a Christmas tree, and so does the image classification model. I wouldn't put my presents under there, but it's saying that this Christmas tree there's a 56% chance that it's a Christmas tree, which is, I'm happy with that, fairly happy. You might have nightmares, but happy with the model. And then let's see, we've got one here, which is Cookie Monster Christmas tree. Yep, even though it's blue, looks like the Cookie Monster is 94% sure that it's a Christmas tree. Let's just remember that this model was trained with only 20 images of each label. 20 images of Christmas trees, 20 images of regular trees. That's pretty amazing if you ask me. There's also a section where you can look at your previous predictions that you've done, which is kind of neat. But once we are happy that our endpoint, our image classification model we created works, we need to publish it. This would say publish. We'd click that. What that does is it gives us a prediction URL. And the next thing we're going to do is hit this prediction URL, this endpoint, using Fiddler, not Fiddler, I always get confused between the two, Postman, and to see what it comes back with. So we're going to take that URL. In fact, I might already have Postman open. Let's have a look. Here's Postman. Let's paste that URL in there. The headers are already pasted in for me. I've got my prediction key here and my content type, just to show you again in case I went too quickly. There's my prediction key. It's telling me to do, sorry, I'm uploading an image, not providing an URL. There's my prediction key, and there's my content type, and then you set the body to the image. That's exactly what we're going to do. So if I open Postman again, I'm then going to go to the body. I'm going to, as a binary, find one of my test images. Let's use one I've not done before. Let's use this one. Okay, this is a Christmas tree wrapped in toilet roll. Don't ask me why. Looks like a naughty elf is to blame. Yep, I hit send. And then I will get some JSON back. He says, there is unsupported media type. That's interesting. Let's try a different image. Demo God's out with me today. Let's do Godzilla. Send. This is working. This was working. Was it raw? Binary. Headers. This is odd. I had this before. Unsupported media type. I'm going to try it one more time. And I'm going to recopy and paste the URL. Because this was working. Let's get the URL before again. Prediction URL. Maybe I didn't copy it all correctly. I think I might have pasted that top one. That explains it. Okay, let's try again. With hopefully the correct URL. Yes. That makes a lot more sense. Okay. Let's try again. I completely forgot what image we're using. Let's choose a different image. It was the toilet roll one. Let's use the toilet roll one because that's fun. Okay. Sending that up. Crossing my fingers. Everyone cross your fingers. Yay, here we go. So we've got the actual response back we're expecting. And it's saying it's effectively 96%, or 97 if you round up, 97% certain, or probability that is a Christmas tree. Even though it's wrapped in toilet roll, it's 97% sure. So I'm happy that my endpoint works. Next thing we're going to do is see how we can call that from a website, because that'd be fun, in my opinion. Okay, so let's open up VS Code. Let's change speeds up a bit. Let's not use Visual Studio. Let's use VS Code. And let's have a quick look at what the end site will look like so you can visualize what all this HTML is doing. So you'll notice this site, which looks amazingly different to the goodyourbaddie.com site, but equally impressive with the design. I'm sure you'll agree. This is at ischristmastree.com. You can go there and test it if you want. And very similarly, you can choose a file. I'm not used the Dropzone for this time. Choose a test image. It uploads that to the Azure function. It comes back with a JSON and it says, here's the label, it's Christmas tree and the degree of confidence as well. And that codes you could get from GitHub as well. I did promise you to look at the code, didn't I? Don't worry, this is a lot simpler than the ML.NET local training. So this is all HTML. The important bit of this code is the JavaScript and the bit that it goes and sends off the file to the Azure, the image classification endpoint at customvision.ai. So here we go. What we're doing here is we are chunking up that image that's uploaded into a blob of an array of bytes, I believe. And then we are Ajax posting it to our endpoint. We are providing it with a couple of headers, including the prediction key and the content type. And there's the post, there's the data. And then with the information we come back, we're saying, get the first prediction, which might be is Christmas tree or is regular tree. Remember, depending on which was higher probability, it will come back in different order. And then get the name of the label and get the probability. And then if the probability is greater than if there's a greater than 50% chance of probability it's Christmas tree, then show the is Christmas tree panel in the code with the name and the probability. I'll show the regular tree. Very, very simple. But yeah, that's all that's doing. So yeah, that's kind of neat. I'll have to do something different for this Christmas. I'll whip it out again this Christmas. Let's just do a couple more. It's kind of fun. I'm really surprised at how accurate this is with just 40 images. I did say we'll try and trick it. Okay, so we've got some fir trees here. Let's do this fir tree. It looks a bit like a Christmas tree, but no light, so therefore it's regular tree. Let's try another one. There we go. That looks like a very Christmassy tree, but no lights. Is regular tree. Okay. And I did try this with my own Christmas tree before and after I put lights on it, and it does exactly as you'd expect. It would say it's a regular tree, then suddenly Christmas tree. Let's do another fun one, and then we'll start wrapping up. There was some upside down trees somewhere. There we go. There's an upside down tree. Completely different shape than the rest of the trees. But it's decorated, and the model says it's 99% sure that it is a Christmas tree, even though it's upside down. It's just magic. It's just magic. Amazing. So let's go back to the talk. I don't think I've got many slides left. So let's just wrap up a bit. We've looked at two different ways of playing around with image classification and machine learning models. We used a local way of training machine learning image classification model locally using ml.net, then uploading that to Azure function, and then calling that Azure function from a website called goodyourbaddie.com. Code is available for you to check out for that one. And also we we trained an image classification model in the cloud at customvision.ai, and then we called that endpoint from another website called ischristmastree.com, and again, some interesting stuff with that one. With that one, we got the degree of probability back, and it seemed to be a lot faster to train, and some really neat features with that product as well. So there we go. Image classification models, training locally and in the cloud. Code's available for the Christmas Tree one on GitHub as well if you want to check it out and play around. So I just want to say with that, thanks for watching this talk. Hopefully that's inspired you to go and play around with image classification models. The learning curve isn't as bad as you think. It can be a complex subject if you become a data science expert, but if you just want to play around with creating an image classification model that's going to identify different types of biscuit or flags or ducks, I can guarantee you'll be able to get something up and running between 30 minutes and an hour. And this sort of technology is solving problems around the world for great purposes. So it's a really good one to learn, a good one to have in your tool belt.